Alright, guys, welcome back. In this video, we are going. In previous video, we discussed some identical ball in the box problems, which is called distribution problem in itself. And distribution problem is of three types. One, when object is distinct and box is also distinct, it is called ordered distribution problem. When object is distinct and but box is identical, it is called unordered distribution problem. And when identical are objects but distinct boxes, it is chocolate like problem also. We discussed the chocolate problem in that unlimited repetition applies. Alright. So let's discuss some questions here. Question is, let's say new topic is outcome of identical coins or ties. Alright. Change the color. Right. So next question is, that's question is here. 10 identical coins are there. So how many outcomes are possible? How many outcomes are possible? Let's say we have one coin which is tossed 10 times. This is equivalent 10 identical coins are tossed, right? So head tail is equivalent to tail head in this case, right? One time head, one time tail, one time tail, one time head. These are equivalent things, right? So how can we do this? Uh, so there are two possibilities. Head, number of heads plus number of tail should be 10. Alright. So identical object. Here are identical object. Distinct boxes. Right? It will be like you have to distribute head and tails in 10 boxes. Alright. 10 boxes. We have uh, uh, greater than equal to heads. Uh, uh, Greater than equal to 10 heads. We have greater than equal to 10 tails. Alright. So this works for this as unlimited. So what can be n is here are 2. N is equal to 2 and r is 10. Right. So what can we do is 12, 11, C, 10. It will be 11, C, 1. Right. Is it like that? No. N minus 1 plus R, C, R. N is 2, 10, C, 10, 11. So 11 C 1. Right. So 11 is the answer. Right. So next question for us is, we have 10 dices, right, are tossed, right? 10 dices are tossed. These are identical dices, right? Identical dices are there. It hanged, bro. It hanged. Right. Identical dices. We have 10 dices, right? So how many outcomes possible from these 10 dices? Okay, all right. How many identical? One dice can give six outcomes, right? So what we are saying is it like that? One plus twos plus threes plus fours plus fives and plus sixes should be equal to number of ones, number of two should be equal to 10 only, right? This is how we do it. And n is equal to 6. 15C6 is the answer. 15C10 is the answer. It will be 15C5 also. Equivalent. Right? Next question is, dice sum or digit sum. Next is the topic. So, what is the topic here is question in this. Three identical dice are thrown. Three identical dice are thrown. Right? How many combinations will give sum 12? How many combinations will give sum to 12, right? So this is a generating function problem. Sum should be less than equal to 6 for this type of paragraph solution for sum. Right. So this type of problem, why it is a note for this, for the this type of, it's a generating function question. All right, it's a generating function question. So it's a generating function question. So what we are doing here, sum should be less than equal to 6, right, for this, right? Right. So dice sum, digit sum are not these are generating function problems. Why these are generating problem problems? Let's see. three identical dice. Well, let's say one dice. Uh, three times. How many combinations will give some 12? Right? How many combinations are there which can give some 12? Right. So one dice here, and how many combinations will give some 12? So how can we calculate this? We can calculate this, but uh, what is the formula approach? It's a generating function approach, all right? So this is not identical to what? This is a it contains constraints in itself, right? So we will solve this, but not yet in further things, right? And constraints, yes. So to cater these constraints, let's take some help from AI, I think. No, from this, right, right. Let's ask some questions from it. Right. Can I type? I don't know. Wow, what a thing. Right. Let's ask this question. Three identical dice are thrown. How many combinations will give some 12? Why this question is a why this question belongs to generating functions but not discrete uh, distribution problems. Right. So this will elaborate much more. When three identical dice are thrown, we want to find the number of combinations that result in some 12. Let's explore this problem. Alright. Okay. So combinations of some 12. We can represent the sum of the three dice x1, x2, x3 is equal to 12, where x1, x2, x3 are the outcomes of three dice. Alright. Each dice has value of 1 to 6. Using the star bar method, we initially restrict one star representing each die. All for all three dice is equal to 9. Why 9? Now we have star and bars method. Alright. Now we have binomial 11, binom 11, 9 possibilities where each dice value is at least 1. However, we need to remove entries where any die value is 7 or greater. We further reduce the equation x1, x2, x3 to equal to 2, since 9 and 7 is equal to 2. Generative function and distribution problem. This question belongs to generator because we use generative function to find the distribution of the random variable. Alright, this is a notable thing, I think. I think it is a notable thing. So, this question belongs to generating function, right? Because we use generative function to find the distribution of random variable. Because we use generating function to find distribution of random variables, right? In the some case, some of the dice are like that. Properties of generator. You under mild conditions, the generative function completely defines the distribution of random variable. Another person, the generating function of some independent variable is the product of generative function. I hope you understood this. No, नहीं मोबाइल पापा नो है नहीं मुझे डलवाएंगे मेरा डेली मुझे डलवाएंगे तो मुझे पूछ लो कल बनाया को बोला मुझे है अच्छा ये तेरी आ रहा है डर गए नाच करो right. So this is the notable thing. Generative function encode information about the probability distribution. All right. So this is the case. It is goes to generating function itself. All right. Let's see. Next, what we will do. Now we are going to discuss some uh, concept regarding this. Right? So this concept is constraints. So constraints. What is constraints? They we have two types of constraints. One is lower constraint. Constraint means conditions, and we have upper constraints. Right. So lower constraints identical ball in the box problem. Lower constraints be like so lower constraints is like, for example, identical ball in the box. We can solve this by this method. Lower constraints type questions we can solve by these methods, identical ball in the box methods. Let's say We have 10 identical 10 identical balls and 3 boxes, right? So how many ways to distribute condition? One constant is no box is empty. So what we are saying here is we have how many balls? Three. We have 3 boxes. All right. Box 1, box 2 plus box 3. This should be equal to 10 because we have 10 balls. So what we are going to do is for box this. All right. Boxes. These are boxes. These should not be empty. This are so greater than 1. Greater than is equal to 1. Greater than is equal to 1. Greater than is equal to 1. All right. Not empty. What means it has uh, one ball already. So we can discuss is box 1 has 1, box 2 has 1 ball, box 3 has 1 ball. How many balls left? 7 only. So this is the simple formula based question now. Now n is equal to 3 here and r is equal to 7. And it would be like 9c7, which is 9c2 as our answer. 36. Right? So next we are going to discuss is, let's say question is here 10 balls and 3 boxes. 10 ball 3 boxes means constraint constraint here is ball 1 is greater than or equal to 2, box 2 is has greater than 3 balls greater than or equal to, box 4 3 is greater than 1 ball. So we can fulfill these constraints because this is total empty balls are 3 to 5 and 6 already. So what we can do is box 1 plus box 2 plus box 3, uh, 5 6 4, it will be like 7 6 c4 6 c2 is the answer. Hope you understood this question. Next is question x1 plus x2 plus x3 is equal to 10. Right? Here but wow, this is similar. Right? And what is the main point here we are discussing in these type of question, lower constraint type questions? Add lower constraint and subtract them from RHS. Right? Right. Next question here is like we have 3 identical dice are tossed. How many outcomes possible if sum of number on dice is 5? Right. So we have 3 identical dice are tossed. How many outcomes possible? Right. How many outcomes possible if sum of number on dice is 5? Right. If sum of number on dice is 5. Right. Dice 1 plus dice 2 outcome plus dice 3 outcome is equal to 5. So this should be 5. So 6 can't be 6. Right? Right? Can't be 6. Outcome of first dice is greater than equal to 1. So it will d1 plus d2 plus d3 equal to 2. Alright. Alright. It can give value some greater than equal to 1. Right. It can't be 0 now. Yes. So it will be like 3 is there, 2, 5, 4c, 2 is answer. Is equal to 6. Right. Now we are going to discuss upper constraint. Alright. We will discuss now here and only. Upper constraint. Upper constraint problems. In this, note to what is this? So now note here is these problems of upper constraint. To solve them by direct formula n minus 1 plus RCR upper constraint allowed only at one variable. This is the condition, right? And there exists and there exists is not. There must not be any upper or lower constraint at any other variable, right? So else we have to use generating functions, right? So number one is chocolate problem with upper constraint, right? Let's say we have three types of chocolates: red, green, and blue, and these are unlimited, but R can be only less than equal to 8. This is upper constraint, right? Is equal to 10. What we will do is, let's say XR plus XG plus XB is equal to 10 is here, right? But what we can do is, we can turn around this upper constraint into lower constraint, right? So what we can do, say 8, right? Should be less than equal to 8? Yes. So we have to uh, give up this constraint, less than equal to 8. R can't be greater than 8, right? So what we can do is, let's say we introduce some y variable, right? So what we can do is, what the constraint on y, right? Let's see. All right, we are going to use a complement method here. We will use complement method, okay, which would be like total minus when r is greater than 8. All right. So what we are going to do, total is what? Total is xr plus xg plus xb equal to 10. It will be like 10 plus 2, 3, 12c10 to 12c2, right? And but to, total is 12c2 is equal to 66. But when r is less than 8, it is xr plus xg plus xb is equal to 10. R is less than is equal to less than 8, only less than 8. We can say less than is equal to 9. All right, greater than is equal to 9. Greater than is equal to 9. This is like that. All right. So this will be greater than equal to 9r. So what we can do is xr plus xg plus xb is equal to 1 only. Right? Just like that. We have to distribute. And this is 4c1. Right? This is 4c1 is the answer. We have to, this is 4 is 3c1. 3c1, the answer is 3 only. So 66 minus 3 is 63 is the answer. All right. Next here is next type of question. N identical ball. We have n identical balls and k boxes. How many ways can be distributed such that no box is empty? How many ways can be distributed such that no box is empty? So we have box 1 plus box 2 dot dot box k should be n greater than 1 all. So we can box 1 plus box 2 box k equal to n minus k, right? So it would be direct formula like n minus k plus k minus 1 c n minus k. It would be like n minus k n minus 1 c n minus k is the answer. All right. Next question here is further. Let's say question 1. We have three variables x1 plus x2 plus x3 is equal to 10. So how many positive integer solutions possible? And positive integer means no integer, no zero included. It should be greater than 1, greater than 1. X1 plus x2 plus x3 equal to 7. 9c7 is equal to 9c2 is the answer. Right. First variation in this type of questions will like first variation, guys. Let's say x1 here plus x2 plus x3 is less than equal to 10. What we are going to do? We are going to introduce some fourth variable less than equal to should be 10. So x1 plus x2 plus x3, right, plus x4, right, one some variable here, and x4 can have value what? 0, 1, 2, 3, and so on, right? If they have total when 10, then 0. If they have total 9, then 1. If they have total 8, they have 2 is equal to 10 only, right? It can be solved like 13C10 is the answer. 13C3. Right. Second variation in this is second variation. Second variation is, let's say, three boxes. One is 10 identical red balls. We have we have 15 identical green balls, and we have 5 identical blue balls. How many ways to distribute these balls in three boxes? How many ways? Distribute. Right. So box 1 plus box 2 plus box 3. Alright. This is the boxes. And should be how many total balls? 15, 10, 20, 10, 30 balls are there. Right. You have to distribute them in all the boxes. How many ways to distribute red balls is this? Right. Distribute red balls is 3 minus 1 plus 10C10. Sub event is this. Sub event 1, sub 1 into second into third. We like 12C2 to 17C2 to 7C2. Let's find this, right? 12 to 10. 6 into 11 into 17 into 15, 16, 8, right? Into 7 to 3. This is the answer. So what is the answer is coming here? Where is the calculator? Calculator is where? This is the calculator, right? So calculate this 6 into 11 into 17 into 8 into 7 into 3. This is done 188,496. 188,496 is the answer. So what is the answer for this? 3 and 30 is this, right? So answer will be for this will be like, where is a pointer, guys? Where is a pointer? Can we change the theme of the board? Hmm? Right. We'll check this. Alright, this is the pointer. Right. So 1332 C3. Is it like that? No, 30. 32 C30. 32 C2. Is like that. Right. And we like 32 into 31. 31 into 16. This is not the answer. Right. This is the answer. Let's check on this. Is that the correct answer? We have three boxes and 10 identical red balls, 15 identical green balls and 5 identical blue balls. How many ways to distribute these balls in 3 boxes? This is the question. Let me check on ChatGPT also how much what answer it will give to us. Right. Oh no, it's not. Certainly, let's find the number of ways distribute 10 ideas. Ooh, is that the case? Right. Uh, this approach is my approach. This is my approach, bro. This is my approach only. Because these all are not identical, right? They are right. It's very important variation. I think this is wrong. This is correct, I think. Right. No, this is not the. You are getting wrong all this time. So ChatGPT is failed, guys, and Pilot have done wonderful things to us. Thank you so much, guys. So, thank you so much. Can we change the theme of this? Let's check if we can change. Alright, we can change all the colors. The board, right? Square, dot, solid. Dots are good, I think. Wide rule, narrow rule, no. Wide rule. Is it comfortable now? Let's change one color white from black to white. A, B, C, In the game of flowers, we can give you some power of fragrance. Good, it's good layout. Thank you so much, guys, for watching the video.